Dear students, let's see this question. A 2 mA capacitor is charged as shown in figure. Here capacitor circuit is given and it's saying that 2 mA capacitor is charged as shown in figure. The percentage of its stored energy dissipated after the switch S is turned to position 2. Initially, this is position 1 and position 2. Initially, switch is at the position 1 and after that, switch is turned to the position 2. And it is asking the energy dissipated after the switch S is turned to position 2. And this question is given in GW Advanced 2011 and here 4 options are given. First one is 0%, 20%, 75% and 80%. Now we'll see how to solve. Again I'm saying advanced questions, no need to worry. Simple basic concepts. Now see here switch S is connected to 1. Switch S is connected to 1. Now we will see here in this Q I will calculate. Q is equal to CV. So here Q can be written as C is how much here? 2. C is how much? 2 μF is given. And here 2 and potential is V. I hope here 2V microcoulombs. I hope you are understanding. Charge formula Q is equal to CV. Capacitance is given as 2 μF and potential is V. So here charge stored in the capacitor is 2V mu C. 2V microcoulombs charge is. And after that we will calculate energy and then initial energy half CV square. Initial energy is half CV square. Now here half C is how much? C is 2. And what is V? Here it is V only mentioned. So I will write this V square. So here 2 get cancelled. So initial energy is equal to V square. I hope you are understanding. Charge stored in the capacitor is 2V mu C. Initial energy of the capacitor is V square. Now we will see the second case. Switch S is connected to second terminal. When switch is connected to the second terminal, just try to understand these two capacitors are connected in parallel. So effective capacitance, if you calculate in parallel, we know effective capacitance C1 plus C2, which is equal to C1 is 2 and plus 8, nothing but 10 μF. Effective capacitance how much? 10 μF. Effective capacitance 10 μF. And after that, if you will see here, this charge, whatever the charge is there, this charge is distributed. Why? Because initially due to this potential, when the terminal 1 is connected, in this capacitor some charge is stored. When terminal is connected to the 2, there is no extra source here. So from this one, the charges are distributed. But initial charges and final charges remain same. According to the conservation of charge will neither be created nor be destroyed. So initially how much of charges are there, and finally also the same amount of charges should be presented. So now if you see here, we'll try to understand here. Initially I write QI and after that final is QF. Initial charge is how much you got? 2V microcoulombs. Final charge you have to calculate. Final charge Q is equal to CV. So C affected. Let it be final potential is, for example, V2. Final potential is V2. So now see here, and 2V mu C can be written as C is how much you got? 10 μF. 10 microfarad into potential V2. So here 2 5s are. So V2 is equal to V by 5 volt. V2 is equal to V by 5 volt I got. But try to understand V2 is equal to V by 5 volt I got. Now I am calculating energy stored. Energy stored, final energy half C V square, half, what is C? C is 10. And how much V we got? V by 5. V by 5 whole square. V by 5 whole square. So here final energy is, here 2 5s are. So I will write 5 into V square by 25. 5 into V square by 25. So we will write 5 5s are 25. So here V square by 5 we got. V square by 5. Initial energy is V square. Final energy is V square by 5. So there is some loss in energy is there. The loss in energy is dissipated in the form of heat. So how to calculate? So delta you can written as percentage of loss of energy in calculating. So how to calculate? U1 percentage, how to calculate? UI minus UF by UI into 100. So I will write here is V square minus V square by 5 upon initial energy is V square into 100. So here percentage of energy or heat dissipated is saying, right? Energy dissipated. So energy dissipated can be written as 5 V square minus V square, 4 V square by 5 V square into 100. So V square cancel. 4 by 5 into 100. 4 by 5 into 100. What is the meaning of 4 by 5? 4 by 5 means 0.8 into 100, which means 80%. That means 80% of energy is dissipated after the switch S is turned to terminal 2. I hope you understood. And from this one, D option is the right answer. Again, no need to worry. The basic concepts, initially calculated charge and energy, and potential is considered here V, and after that also I am calculating the potential and energy calculated. So loss of energy calculated in terms of percentage. I hope you understood. Thank you.